M. NARASIMHARAO, lecturer in physics. Today I am discussing previous year question from ray optics of 2021 JEE. An object is placed beyond the center of curvature C of the given concave mirror if the distance of the object is d1 from center of curvature C and the distance of the image formed is d2 from center of curvature C, then the radius of curvature of the mirror is, according to the given information, I have drawn one diagram. In this problem, there is a one concave mirror. This is the pole of the concave mirror. This is the center of curvature of the concave mirror. This is the principal axis. This is the principal focus. The distance between the center of curvature and pole of the concave mirror we are calling as the radius of curvature of the mirror. This is the concave mirror. This is the center of curvature. This is the pole. The distance between center of curvature and pole we are calling as a radius of curvature. Radius of curvature. We are having one formula. This radius of curvature is equal to the 2 times the focal length. The radius of curvature is equal to 2f, where f represents a focal length. Now this is a one focal length. It is equal to focal length. This distance is small f. This distance is small f. F plus f, 2f. Radius of curvature r is equals to 2f. They told very clearly, object is placed beyond the center of curvature. Object is placed beyond the center of curvature at a distance of d1 from center of curvature. Distance between the center of curvature and this object is d1. Now, object distance means distance between the pole of the mirror and the object. Now PO distance we are calling as object distance. PO can be written as PC plus OC. PC is equal to radius of curvature plus distance between object and center of curvature is given as d1. This distance is r, this distance is d1, this is r plus d1, r plus d1. Now r plus d1, r is nothing but 2f, r is nothing but 2f, d1 I am writing d1. According to the sign convention, object distance of concave mirror is taken as a negative. Now, when the object is beyond the center of curvature, its image is formed between the principal focus and the center of curvature. This is the image. The distance between the pole and the image we are calling as image distance. Image distance is represented by V. Now, from here to here, this is nothing but a radius of curvature. Now, from center of curvature, image distance is given as a d2. This is r. This is r, this is a d2. Image distance is equals to, this distance is 2f, this distance is d2. This is 2f, this is d2. We need a distance between pole and the image. Image distance, this is 2f minus d2. We need this distance. Image distance is equals to 2f minus d2. This is nothing but the image distance. Image distance is represented by now r minus d2. Now this is the image distance is this one, r minus d2. R is nothing but 2f. This is a 2f. This is a d2. It is nothing but 2f minus d2. According to the sign convention, in the case of concave mirror, here image is formed on the same side of the object. Image distance also negative. Image distance is v. It is a negative. Otherwise, now you consider it is a x-axis. Now this is a y-axis. It is a x-axis. It is a y-axis. It is the origin of the coordinate system. Image is formed on a negative x-axis. I am taking this image distance is a negative. Object is on a negative x-axis. Object distance is a negative. Regarding the concave mirror, focal length of concave mirror is a negative. It is also on a negative x-axis. A focal length is a negative. Now, I am applying a mirror formula. According to mirror formula, 1 by f is equals to 1 by u plus 1 by v. U means object distance. V means image distance. 1 by focal length. Focal length of concave mirror is negative. F means minus f. F means minus f. 1 by U means object distance. U means object distance PO. PO it is nothing but minus 2f plus d1. Minus 2f plus d1 plus 1. I am writing 1. V means image distance. Image distance also negative. Image distance also negative. Image distance is minus 2f minus d2. 2f minus d2. Now minus taking common, minus is cancelled out. Minus is cancelled out. 1 by f is equals to minus cancelled out. 1 by 2f plus d1 plus 1 by 2f minus d2. Taking LCM, 2f minus d2 into 1. 2f minus d2 into 1. 2f minus d2 plus 2f plus d1 into 1. 2f plus d1 by 2f plus d1. 2f plus d1 into 2f minus d2. Now 1 by f is equals to 1 by f is equal to 2f plus 2f, 4f plus d1 minus d2 by 2f into 2f, 4f square, 2f into d2, 2f into d2 minus 2f d2, d1 into 2f, d1 into 2f plus d1 into 2f, 2f d1, 2f d1, d1 into 2f, 2f d1 plus into minus d1 d2, d1 d2. Now on cross multiplication, on cross multiplication, on cross multiplication, on cross multiplication. Now on cross multiplication, f into this one, f into this one, f into this one, small f into 4f, 4f plus d1 minus d2 is equals to this total term into this one. total term into this one, 4f square, 4f square, 4f square plus 2f d1 plus 2f d1 minus 2f d2, 2f d2 to minus d1 d2 minus d1 d2. 1, 2, 3, 4 terms, 4 terms. Now here please listen here. F into 4f, 4f square, f into d1, f d1, f d1 minus f into d2, f d2 is equals to 4f square, 4f square, 4f square plus 2f d1 plus 2f d1 minus 2f d2 minus 2f d2 minus d1 d2 minus d1 d2. 4f square cancel, 4f square cancel, minus 2f d2 comes to this side plus 2f d2 minus f d2 minus f d2 minus f d2. Here f d1, I am writing f d1, is plus 2f d1 comes to this side minus 2f d1, 2f d1. Here minus that is equals to minus d1 d2 minus d1 d2. 2f d2 minus f d2, 2f d2 minus f d2, nothing but f d2. f d1 minus 2f d1 minus f d1 is equals to minus d1 d2. Now here f I am taking common, f common, d2 minus d1 is equal to minus d1 d2. Here d2 minus d1, I am writing d1 minus d2. Now f into, here d2 minus d1 I am writing d1 minus d2. Here I am taking minus common, that is equal to minus d1 d2. Minus minus cancelled. F r is equals to 2f. F means r by 2. F means focal length of, there is a relation between the radius of curvature and focal length of the mirror. Capital R is equal to 2f. F is equal to r by 2. F means r by 2 into d1 minus d2 is equals to d1 d2. 2 comes to numerator. 2 comes to numerator. Capital R is equals to 2 comes to numerator, 2 into d1 d2 divided by this term comes to denominator d1 minus d2. This is the formula for this is the radius of curvature, radius of curvature, radius of curvature of the concave mirror.